Hello everyone, welcome to this tutorial on the design factor of the final project in the course TDD49. I'm going to walk through all the architectural details involved in all three labs in the course and try to explain some details which are important to us and try to simplify some details which you had some questions about. All right, shall we begin? As explained earlier during the lectures, the project will consist of three different layers. Each layer will be implemented as a separate lab. So we shall start with the logic layer, and then we'll continue with the presentation layer, and then we will complete the project by implementing the data tier. Apart from the requirements for each lab, it is very important that you will follow the overall requirements and think of those requirements throughout the whole course of the implementation. When it comes to lab 1, the logic tier, there are some requirements specific to the lab or this tier. The first one is to have two different subcomponents, which allows us to change each of the subcomponents on demand. So the first subcomponent will contain the logic. The second subcomponent will contain the rules. And of course we have a third one which is about the data types. So data types are very important because they will hold the whole data. When it comes to presentation tier, there is one requirement when it comes to desktop applications. So WPF will be used. No Windows Forms, it's not allowed. But if you're implementing on some Linux system, and as you know, WPF is not available on Linux systems, so you can use any counterpart library to develop the UI. Okay, when it comes to data tier, you can choose any underlying technology to store the data, but it is very important to use LINQ for doing the queries, and this is kind of one of the most important things that we will look at when it comes to code examination. The simplest approach is to use XML, an XML file or a JSON file to store data, but you can use any database. MySQL is one example, but you can also use NoSQL databases like MongoDB. You can use the web service-oriented storage like a Firebase storage. So it's up to you. But as long as you use LINQ, any choice would be fine. All right, I continue with some sketching about the whole architecture involving all three labs. I'll try to give you some idea about how the whole architecture will look like by the end of the project. Of course, this is not the only approach, so this can be considered as some kind of recommendation. But of course, you can come up with some other designs and you can discuss it with us. Okay, so the three-tier architecture, it consists of three different tiers. The first one is the presentation tier. I have some difficulties writing with this thing. Okay, so I mess it up a little bit. Okay. So, okay, the presentation tier, and then it comes to the logic tier, and it comes to the data tier. So 3 different tiers working together. So when it comes to the logic tier, one question was, why would we have 2 different subcomponents? Aren't the rules as part of the whole logic? The answer is yes, but it happens that we want to change the rules of the game. So if it's the case, having a subcomponent which holds only the rules can help us to change the rules without affecting the rest of the logic. So a subcomponent like the rule manager or state manager will help us to have some kind of abstraction over the rules. And at the same time, we're going to have some logic which will be available, which will be seen by the presentation tier. And well, of course, we're going to have some parts. Of course, the logic, not all of the logic is available, is visible to the presentation tier. We can have some methods, some classes which are hidden, private inside of the logic tier. Okay, and of course we're going to have the data types, very important. Our data types are designed to hold the whole data consumed in the logic tier. So that's how it works. So these are the public functions methods. They may communicate with the private methods, and at the same time they will communicate with some methods inside the rule, or the state manager or the rule manager. You can think of the rule manager or state manager as a class, a bunch of classes, a sub namespace. So it's up to your design technically. At the same time, we're going to have the presentation tier. This is the part that we define. We use XAML to design the whole UI, and then we're going to define event handlers on different components. So the most likely scenario is that there are buttons, and on each button there are going to be event click listeners, which are going to allow us to pick up any event or any click event on the buttons. So something happens, the user clicks on some button. So technically this will lead to some function call in the presentation tier, and this will lead to some function call from some method inside the presentation tier to some method inside the logic tier. So this can be, for example, move. So there is a move function here defined here, but as I mentioned earlier, we don't know if the move action is allowed or not. That's why the logic will ask the state manager, is move allowed? So there is going to be a function in the state manager, is move allowed, and then this is going to return true or false. And technically this is going to tell the move function if it can continue with the rest of the process or not. Of course, we need to send data between the tiers or between the functions. One of the requirements says that if you want to send data from one tier to another tier, you're going to use the uniform approach. So the uniform approach basically says that you're going to use entities for passing data. So for example, if you're passing coordinates like x and y, of course we're talking about indexes here, and then you can have like a move entity which has 2 fields, x, y, and setters and getters and some constructor. So this is technically how we pass the data between the two tiers. Okay, so when it comes to data tier, that's kind of the same thing. We're going to have functions here, which allow us to manipulate the data. So there is some kind of abstraction here involved. So the data relies, the data can be on the same server, or it can be somewhere else around the world. But the thing is that because of the abstraction, we don't know and we don't care technically. I mean the code existing in the logic tier. So technically, when communicating with the functions available in data tier, we're gonna ask for some certain operations. For example, save data, load data. So this can be save, this can be load. And this is exactly this is technically the simplest approach. So we can go for more complicated approaches, but the simplest approach is that you call some save method which stores the whole state of the game, and for passing the data you're going to use your data types. So use your data types for passing the data to the save function. And yes, still you're following the uniform approach requirement because you're using an entity for passing the data. One important thing is that the functions existing in the presentation tier will not call functions in the data tier. So everything goes through the logic tier. So the logic tier is responsible for calling those functions in the data tier. Okay, so one of overall requirements talks about the exception handling. So if something goes wrong in one of the tiers, which is caused by the data, for example, coming from some other tier, or caused by any of the code existing in any of the tiers, an exception will be thrown. So, for example, if something goes wrong when it comes to loading, an exception will be thrown. It will be caught by the logic tier. If there is not much you can do, you can just rethrow the exception and will be caught in the presentation tier. So technically, the whole chain is very important because if something goes wrong, one of the things that happens that you may want to give the user some feedback. So it's important that you're going to catch the thrown exception in the presentation tier and tell the user, okay, there were some problems about reading the data from the file, so you cannot load the previous game. So you're going to start a new game, for example. So one of important things in the project is that to define custom designed exception classes. So you can use the exceptions already existing in the SDK, but it is important to have custom design classes because some problems are specific to the program, and for those specific problems, you're going to have your specific classes. So for each tier, we're going to think of the exceptions. So each tier is going to have its own exception classes. When it comes to the presentation tier, it might not be the case because the presentation tier does not have that much of code, but logic, I would say. But it's more important in the presentation to catch the exceptions. But it is still possible that you might find some specific problems can happen in the presentation tier, so you're going to have your own exceptions in that tier as well. Okay, so that was some sketching. I hope it might address some of the common questions. So please contact us if you had any further questions. Thank you for watching and listening.